Okay, let's talk about naming the shape first. So I would say this one has an x and a y squared, but there's no x squareds in it. So what kind of shape is it that has an x in it, but no x squareds, and a y squared? It's a parabola. Horizontal parabola. Okay, so here's what I'm going to do. X plus 41 equals, and I'm going to move all the y stuff over. Okay, so negative 3y squared and minus 18y. Okay, now I'm going to GCF the negative 3 out. So y squared plus 6y plus blank. This is the process. So do you remember trinomials? You always want this perfect trinomial, and it has to be a simple trinomial. Okay, let's go back here to grade 11. So what do? You take half and square it. So what's half of this? 9 squared. So this would be 81, which, do you remember we wrote x plus 9 squared? Like that's the perfect square. Remember that business? So that it does what? It multiplies to the end, adds to the middle, right? That's what we always do with trinomials. Multiply to the end, add to the middle. Okay, so what number would have to go on this blank? Half squared is 9. Okay, you created something that didn't exist, so what would happen to a teeter-totter? It would change, right? How do you balance it out on the other side? And it's not to add 9. How would you balance out the other side? It has nothing to do with 9. The number is not going to be a 9.
What?
Oh, 9 times negative 3.
Negative 18. You added 27.
Got what you mean. I got what you mean.
Yeah.
I'm going to minus 27. Because technically, what did you do here? You minus 27. Okay? Okay, so finalize it. So x, what is that? 14. Is that 14? Right?
Yeah.
How's my mental math? And then we're going to write this as a perfect square. So what multiplies to 9 and adds to 6? So it needs to square to that and double to that. Multiplies and adds. Okay, so what would this kind of generally look like? Where is the vertex? Negative 14, negative 3. I'm just going to draw like a super general picture here. Negative 14, negative 3. And which way does it go? Up, down, left, right. It's left because the negative 3 it kind of looked like that. And what would I do here? I would do 1 and 3. You know what I mean with the pattern there? I would do 1 and 3 left. Okay? Okay, next one. First, name the shape. What am I looking at? I'm looking at that alone. That's it. That tells me the shape. Whoa, can't even see the pitch. I'm looking at just those two things. 3x squared plus 3y squared. I already heard it. It's a circle. It's a circle. Okay, so here's what we're going to do. We are going to group our x stuff together, which is looks like it's kind of already done. Group our y stuff. Group x stuff, group y stuff, move the number. Okay, now out of my x stuff, I'm going to GCF a 3 out. So x squared plus 6x plus blank, because as soon as I have a simple trinomial, I can do this. And then I'm going to do the same thing over here. I'm going to GCF a 3 out of the y group. Plus blank. Do you notice, make sure people forget to do it out of the second term. You got to take the 3 out of everything, right? How does that look? Okay, here we go. Half squared is 9. To balance that creation, I have to add 27 to the other side. Because this is an add 27, foiled out, it's add 27. Half squared, you get a 1. Half squared is 1. To balance that out, I need to do add 3. Okay, so we're going to go 3 brackets perfect square plus 3 brackets perfect square equals 36. Okay, so what am I doing here? What kind of number will multiply to 9, add to 6? What would multiply to that and add to that? Okay, everybody has a little sheet that I gave them. How should the circle look at the very end?
Round?
Or like the equation. It should look round, yes. It needs to look like this. So I'm going to divide everything by 3. So x plus 3 squared plus y minus 1 squared equals 12. Okay, so when I would graph this circle, what's the coordinate in the middle of this thing? Should be -3, +1. And this one might be a little tricky. I don't think we've had an example like this. What would the radius be when I'm on my graph moving? The square root of 12. So on a graph, I would have to move 3.46. So on a graph, you have to kind of put that into a decimal and just move that. Okay, so that was the first case where the radius wasn't a nice, pretty number. Okay, what is the next shape? So here's what I'm looking at. A 4x squared and a minus. So as soon as you see a minus, anybody know what the minus means already? hyperbola. It's a hyperbola. And what kind of hyperbola? What, there's a positive x squared and a negative y squared. That means horizontal. Okay, so I'm going to go x grouping, y grouping, move the number. X groups, y groups, move the number. Okay, so I'm going to GCF the 4 out, plus blank yet. Okay, so there's my GCF stage. Okay, complete the square is the next step. So half squared, half squared. Next step is to make sure your teeter-totter gets balanced out. So this would cause me to add 16. So balance it back out with 16. And this would be subtract 48, right? So I have to subtract 48. Okay, now I'm going to turn them into perfect squares. So don't forget it's multiplying to the end and adding to the middle. Multiplies to the end, adds to the middle. Okay, now here's my hyperbola stuff. I need to make it look like a 1. It has to end with a 1 here. So what should I do as my next step if that's what I want my final format to be? I'm going to divide by 12. To get that 1. Okay, so now what I'm going to do here is I'm going to reduce. There's a 4 and a 12, so they both can be divided by 4, which means there would be a 3 on the bottom. And then here there's a 3 and a 12, so I'm going to reduce this by a 3 and a 3. So that would turn into a 4 on the bottom. There you go. Does this look exactly like your paper? Okay, so quick snapshot of what it would look like. What's the coordinate of the center? -2, 4. How much should I go out horizontally? Root 3. I should go 1.73 on a graph away because that's the root of 3.
You memorized the root of 3?
No, I just typed it in before you.
Oh,
Did it look like I was really smart?
Is that where you're going for?
Yeah. And then vertically,
Root of 4.
the root of 4, which is
obviously
2. I can do that one in my head. Then you draw These are all asymptotes, so they're not, you shouldn't have any technical writing on your paper yet. It should just be dashed stuff. And then draw a diagonal asymptote, and we said before it was a horizontal, so you have to open up horizontally. So this is a vertex. So that's the general idea of that one. Okay, that's it. How does that seem? So identifying those shapes. Okay, kind of think about what you have. So again, I kind of put that on this sheet. So you can see here, to know it's a circle, I have the same amount of x squareds and y squareds. But here it's an ellipse because I have different amount of x squareds and y squareds. As soon as you see something with a subtract, then that's a hyperbola. As soon as you see one of the variables doesn't have a square, it's a parabola. Okay, so this sheet you can use for reference with that. What's it going to look like on your test? This isn't involved in your test at all. I will give you this formula sheet here, just this part. But like I do with the unit circle, I'm going to give you this blank and you have to write down. So you have to have it memorized, and I'm going to rearrange it. The order is going to be all mixed. So you're going to get this in a mixed, fill it in. Okay, then when I give you your actual test, I will give you this. Okay, this column is just for your notes right now. You do not get that on your test.